Hi, this is Niki Sensei. Today I'm going to continue answering the physics problem that we started from last time. So, going back to the problem, the continuation of the problem reads, after the girl pushes the car, it collides with a stationary wooden block. The direction of the car's momentum does not change, but its magnitude decreases by 60%. The speed of the wooden block after the collision is 2.6 meters per second. Show that the mass of the wooden block is 70 grams. So, from the initial problem, remember we have the girl pushing the toy car, and then the car started from zero, from rest, and it has a final velocity of 2.5 meters per second here. So can you imagine what happened next? So after the girl pushes the toy car, it collides with a stationary wooden block. So the toy car would have been moving then with a velocity of 2.5 meters per second, which is the final velocity from the first problem. So the toy car would have been moving by 2.5 meters per second and then hitting the stationary wooden block, pushing the wooden block and gaining speed of 2.6 meters per second. So in this problem, it's asked to show the mass of the wooden block, K. So recall that, that's initial momentum should equal final momentum. And what is momentum? Momentum is defined as mass times velocity. So let's identify the mass and velocities of the two objects. So we have, I'm gonna draw two columns here. So I would have car and block. So I need to know the mass and velocities. So the mass of the two objects do not change because it's not stated in the problem that the masses of the objects change. So the mass of the car remains at, based on the first problem, the mass of the car remains at 0.12 kilograms. The mass of the block is something that we don't know. We're supposed to look for it. And then the velocity of the car, the initial velocity would be the velocity of the car before collision. So that would be the final velocity in the first problem, which is 2.5 meters per second. And its final velocity would be, let's read the problem. So the problem states that the direction of the car's momentum does not change, but its magnitude decreases by 60%. Since momentum is just mass times velocity, and since the car does not change its mass, therefore, if momentum decreases by 60%, its velocity would have decreased by 60%. So what remained is 40% of the velocity. Does that make sense? So 40% of 2.5 would equal to 1.0 meters per second. And as for the block, the initial velocity of the block would be, reviewing the problem, we know that the block was in a stationary position, so that implies that its initial velocity is 0, and its final velocity is, based on the problem, it's 2.6 meters per second. With that, we can now solve for the conservation of momentum. So writing down, we would have initial momentum of car, V initial of car, plus initial momentum of block, V initial of block, equals final mass of car times V final of car plus final of block and VF block. Plugging down the values, we would have 0.12 kilograms times initial, which is 2.5 meters per second. Since the initial velocity of the block is 0, we cancel out the second term. So we cancel out the second term of 2.5 meters per second. And then plugging this in, we have 0.12 kilograms times 1 meter per second plus final mass is something that we don't know, so I'll still write down final mass of the block times velocity of the block final would be 2.6 meters per second. So plugging down, I would have 0.12 kilograms times, I'm going to use a calculator now. So I would have so I would have 0.12 kilograms times 2.5 minus 1 meters per second, MFB, and then divided by 2.6 meters per second. The final block would be 2.5 minus 1 is 1.5, 1.5 times 1.5 times 0.12 divided by 2.6. So the answer is 0.0692 kilograms. But I want to express the answer in grams, so that's equal to, I will use dimensional analysis to show you how it works. So I would have 0.069 kilograms times, the conversion factor is 1 kilogram equals 1,000 grams. So that's 1, 2, 3. I would have 69 something grams. Or I have to express the answer in how many significant figures? 2 significant figures, because the least number of significant figures in this problem is 2. So that's 69 grams, or around 70 grams. So we were able to arrive at the answer. And then the next question asked for, deduce that the collision between the toy car and the block is inelastic. So, okay, based on collisions, like elastic and inelastic collisions, we know that a collision is elastic when kinetic energy is conserved, and collision is inelastic when the kinetic energy is not conserved. So we need to solve for the kinetic energies of the two bodies. Kinetic energy is defined by 1/2 mv squared. So let's get the kinetic energies of the two objects, initial and final. So we need to solve for 1/2 m of the toy car, v car squared, plus 1/2 block, v block squared. And then for the final, 1/2 m car v car squared plus 1/2 m block v block squared. So based on the given, I will just plug down values. I have 1/2, initial is 0.12 kilograms. Initial velocity is 2.5 meters per second and square, plus 1/2 mass of the block is 70 grams. 0 grams, kilograms. Yeah, 0.07 kilograms times initial velocity is 0. Maybe I should write down the final values, the final components using a different color. So maybe I'll use red. Later, I'll solve for them later. So now it's 1/2, 0.12 kilograms, 2.5 meters per second squared. And this simplifies to 0. And this whole term, if I plug in the calculator, I will get 2.5 times 2.5 times 0.12 divided 2. Okay, I will get 0.375 joules. And for the final kinetic energy, I would have 1/2 mc/v squared plus 1/2 m block v block squared. So it would be 1/2 0.12 1 squared plus 1/2 7 kilogram, and final velocity is 2.6 something. So I will now plug that in the calculator. I would have around 2966 joules. Since these two values are not equal, therefore, the initial kinetic energy is not the same as the final kinetic energy. Therefore, kinetic energies are not conserved. That makes the collision between the toy car and the block inelastic. Okay, so that's it for now. I hope this helped you in reviewing for your physics exams. Bye!